We'll see how we go for time. Hopefully I can get through everything. This talk was originally prepared for the full slot, but I think we can cram it into 25 if I talk really quickly and don't go off on too many tangents. But essentially, I would also say that really this isn't just a talk about replacing legacy message queuing solutions with Rabbit. It's about how you can potentially integrate RabbitMQ and utilize message queuing within legacy environments. I live in a rather interesting world where I'm dealing with customers that have, genuine legacy. They have code written in COBOL, BASIC, Fortran that runs on mainframe systems, on OpenVMS systems. If you're familiar with OpenVMS, I won't bore you with those details. We can discuss later. But my role is essentially helping customers to modernize those legacy environments. And quite often that comes down to the introduction of message queuing. It's quite uncanny how many times throwing a message queue into the mix can actually solve a lot of customer problems. Customers will have these legacy applications that have served the business well for decades, and they continue to do so. And the CTO goes out and buys some new shiny thing, and all of a sudden the customer's thinking, well, how does my crusty old thing talk to the shiny new thing? Message queuing is obviously a very, very good solution for that. So just a little bit of background first of all, and this is the slide that probably overlapped with the Code Beam one. It's my good friend Chris. My involvement with Erlang, with RabbitMQ, dates back to a rather interesting day, 4th of November 2008, which was when Barack Obama was elected president of the US. And Chris and I had a very, very long day. Honestly, we'd encountered drug dealers, pimps, rednecks riding on the back of pickups carrying guns. Our phones had run out of power. We were in the middle of nowhere. Life was tough, but we survived. And at the end of the day, we discussed a whole pile of things. So Chris and I worked for the OpenVMS team in HP at the time, and we were looking for open source message queuing solutions for the OpenVMS platform. And I'd done some work with the original AMQP implementation created by Peter Hitchens from Imatics, working with John O'Hara at the time. I'd ported that to the OpenVMS platform, but Peter had pulled out of the AMQP committee. We won't go into those details. But we were looking for something else, and I'd stumbled across this thing that was in its early stages, I suppose, in its genesis, shall we say, RabbitMQ, and it was written in this crazy language called Erlang. So with the help of a little bit of alcoholic beverage, Chris and I hatched a plot, and the rest is kind of history. So since around that time, one way or another, I've worked with RabbitMQ, I've worked with Erlang, and as I say, I've worked with customers all around the globe, helping them to modernize their legacy environments using these and indeed other technologies. How many of you have read Alvaro's book, the first book on RabbitMQ? Okay, not so many. That's perfectly all right. All you've got to do is just remember this diagram, which is actually quite a good diagram that illustrates the history of message queuing, up until the date that the book was published, a little bit thereafter maybe. There's actually an omission from that, and that's kind of the case study. We'll get to that sooner rather than later. Message queuing has been around, as I say, for a long, long time, and there are different variants. You've got TIBCO, you've got IBM MQ, you've got an assortment of other products. They all share certain things in common. I'm sorry I've used the word asynchronous. I really quite enjoyed Sam's talk this morning, but I have at least qualified what I'm referring to by asynchronous there. And I totally agree with him that putting words around things sometimes without appropriate context is very, very dangerous. But to the topic at hand, all message queuing systems share a lot in common, one way or another. We all know this. Okay, and they use some common terminology. We refer to messages, queues, routing, consumers, producers, persistence, all that sort of good stuff. No problem. And it's probably fair to say that over the years, different message brokers have borrowed ideas from each other. I think John O'Hara and the AMQP committee probably borrowed a few ideas from MQ, and I suspect MQ then probably borrowed a few ideas back with some of their enhancements around 2010, a little bit later than that. Could be wrong, happy to discuss. But there are differences. And this is kind of where AMQP came in, I suppose. I mean, I'm sure you all know the history. But these different products, TIBCO, MQ, etc., they all implement different wire protocols. They have different APIs, different message properties, header fields, whatever you want to call them. They potentially provide different guarantees, different levels of service, quality of service, whatever. And these could be construed as being relatively not so bad basic differences, but there are also bigger differences. One of the products I'm going to talk about actually does content-based routing, where the message queuing system actually looks at what's in the message and routes it based on that. And not too enthusiastic about that. But when you take all of these differences and add them up, this is what John O'Hara referred to as middleware hell. And you know, he was in JP Morgan Chase at the time. This is back in the 2000s, I guess. And every project, you found yourself with some new integration technology, and it needed to talk to some other integration technology. The protocols didn't match up. You had to develop gateways. You had to employ people that knew about all of these different products and so forth. Has to be a better way of doing it. It's costly and it's difficult to maintain. Okay. And if you haven't seen it already, John O'Hara did quite a good talk at QCon in London recently, where he just talks about the history of AMQP and how much money it basically saved JP Morgan Chase and others. This is actually a slide from a presentation by Alexis Richardson, who some of you I'm sure know was essentially the founder of RabbitMQ. Not necessarily from a technical perspective, but certainly in terms of getting the ball rolling and appreciating the opportunity with respect to AMQP. This slide was actually from 2008, Alexis presenting to some people from Microsoft, encouraging those people from Microsoft to be more open and adopt open standards and open source technologies and essentially make it a level playing field, and to try and describe to them how working in this way would actually be beneficial to everybody. And you know, I don't know that Alexis had any sway in the matter, but I think over time this has kind of happened, okay? But the whole idea from its inception with AMQP was for it to be a universal solution to messaging, any programming language, any model, any payload, any platform, reliable, etc., etc., etc. You know the details. Okay. Replacing proprietary. Okay, this is where I again apologize to my friends from IBM, my ex-friends from IBM. Like I said before, you know, AMQP borrowed from the past and has kind of added some extra bits and pieces, and of course it's a standard. This is a good thing. Okay, and what you find if you look at some of these, I'll say TIBCO because I don't think there's anyone from TIBCO here, apologies if there are, but if you look at these legacy message broker technologies, right, and then you look at RabbitMQ and you look at AMQP, there's actually a pretty good mapping. If you want to rip out TIBCO and replace it with RabbitMQ or indeed another AMQP implementation, in general that's going to be fairly possible. And in many cases, you'll actually find that RabbitMQ opens up some new possibilities for the customers in question. They can maybe do a little bit more with it from an integration perspective one way or another. Feel free to take difference with me on that. That's fine. Back in 2013, so I said I've been doing this stuff for a while now. Back in 2013, I wrote this blog post where I had actually integrated, essentially integrated RabbitMQ with COBOL code. So from a COBOL application on an open VMS system or on any system, it really doesn't matter, I could interact with RabbitMQ. So this gets back to the point I said right at the start about, you know, the talk isn't just about ripping and replacing message brokers, but it's about the ability to use some of these modern technologies, some of these modern message queuing solutions to actually help customers who have a bit of a legacy dilemma to integrate with other systems and do more with those existing legacy systems. And, you know, love it or hate it, COBOL's not going anywhere very fast, right? Just about every day there are trillions of dollars worth of transactions being handled by systems written in COBOL. 43% of all banking systems in the US and probably around the world actually are implemented in COBOL, handling 95% of ATM transactions and so on and so forth. You can read the details, right? There's a lot of legacy stuff out there. It's not going away quickly. But like I said, you know, you'll get customers that I quite often deal with say, well, what are we going to do with the stuff? You know, our staff who actually know how to maintain the code are retiring. We think it's some sort of desert island that information can't escape from and we can't get information into it. What can we do? And this will sometimes prompt fairly bad decisions on the part of those organizations. They'll launch into some rewrite or possibly today some AI-infused conversion of COBOL to Java, which is probably destined to end fairly badly, because they think this is the right thing to do. Maybe it is, but possibly you can actually take a more incremental and, shall we say, less invasive open heart surgery approach and do things gradually. Introducing a message broker to facilitate more open, standards-based communication with other more modern systems within your enterprise, then allows you to start moving bits of functionality almost at your leisure, assuming you can tease apart that COBOL monolith, which isn't always possible, of course. So how do we do this, right? So there are APIs for RabbitMQ in just about every language imaginable, but languages like COBOL, Fortran, and BASIC don't feature on the list, okay? The solution's actually fairly simple. Yeah, okay, you could write a native API in pure COBOL if you were feeling unwell and then required psychiatric treatment. A better approach is to, say, take something like RabbitMQ or the Bloomberg C++ library or something like that, and essentially use this to create an abstraction layer that can be called from COBOL, right? Create just a fairly thin veneer of C code that can then be easily called from your legacy application, COBOL, Fortran, whatever. It's easy, kind of almost obvious. There are some things that you have to worry about, of course, because these legacy programming languages pass variables in different ways, and you know, if you've ever looked at COBOL, there's a myriad of fascinating and interesting data types. They're not just ints and floats and strings and things. There are some fairly wacky decimal data types and so forth. So you do need to understand some of those nuances if you're going to do this kind of mixed language programming and come up with some sort of API that you can use from your legacy COBOL, Fortran application, whatever. Okay, so I mean, essentially what you end up with is pure and simple. Let's say we're using RabbitMQ. We've got our COBOL application code. We just write a simple little wrapper API, C code. It's a few days' work. It's not a big deal. Take into consideration some of the subtleties that I mentioned, and wham, we're quite happily exchanging messages with Rabbit or with Azure Service Bus or whatever your favorite technology might be. It doesn't really matter. The approach is equally applicable. Okay. Like I say, you've got to take into consideration different data types, different parameter parsing mechanisms. Reentrancy is actually quite an important one. For example, if you're working on the OpenVMS operating system, things like the COBOL runtime library or the Fortran runtime library are not thread safe. Okay, you can get bad things happening if you have threaded code mixed with COBOL. It's not good. So you just need to be cognizant of some of these things, but for the most part, it's not too difficult. Okay, so moving on quickly to a case study. We've figured out a strategy that we can use here for doing this stuff. Now remember the diagram from about slide 2 or 3. The bit that Alvaro forgot was a product called DEC-MessageQ, which came out around about the same time as IBM MQ. And it was created by Digital Equipment Corporation as essentially Digital's TIBCO, Digital's MQ, whatever. And it was actually a very, very good message queuing product back in the early 90s. It was heavily used around the world, financial services, manufacturing, telecommunications. It's still out there today. We're not sure how many of our customers are still using it, but quite a few, okay? So I had one such customer. What do I do with this? It's no longer supported. How do we deal with this particular problem? DEC-MessageQ got rave reviews when it came out back in the day. It was considered, you know, superior in this particular review to MQ and a few other products that were around at the time. But Digital Equipment Corporation, bless them, had some absolutely fantastic technologies back in those days, but they were not a good marketing company by any stretch of the imagination. So they really didn't promote this technology at all well. Eventually it was sold to BEA Systems, who were subsequently acquired by Oracle, and Oracle really did very little with the product since that acquisition in 2008 or whenever it was. Okay, now we, the company I spend most of my time working with, have recently ported the OpenVMS operating system to x86. Yay, VMS finally runs on x86. This DEC-MessageQ product will never ever be ported to OpenVMS x86. Okay, Oracle just aren't going to do it, not going to happen. So this causes a problem for some of our customers. What do we do about it, right? Customers have a lot of infrastructure based around this stuff. They don't want to do open heart surgery on their legacy code. They essentially want something that will just slot in there and replace deck message queue with minimal disruption. A cunning plan. Okay, it's not too hard. Thinking back to that little wrapper API thing that I mentioned before, what we can actually do, deck message queue implements a fairly small and concise set of API functions. So all we actually have to do is create a wrapper API that projects exactly the same interface, right? Same function name, same argument lists, same return codes, etc., sitting on top of RabbitMQ or similar such API. And we can essentially create a drop-in replacement API that means the customer doesn't have to change their application code. They just have to relink everything and the world will be good. Okay? Good theory, not quite that simple. As I say, in general, this theory works. But if you look at deck message queue, it does some things that overlap very, very well with RabbitMQ, or some things that are trivial for RabbitMQ to handle. It doesn't do routing, it just publishes messages straight into queues. Okay, so null exchange, no problem, easily handled. It has a basic broadcast facility. Okay, it's a fan-out exchange, no big deal. Does some other things. It provides journaling functionality. I think that's probably on the next slide. Well, that's no problem. We can just have a stream in RabbitMQ for that. It's not a problem. So there are things like that overlap very, very well. Consuming is a little bit different. Deck message queue allows you to do some naughty things in terms of how you consume messages. They can be, you can consume based on priority. I want to consume only messages that have priority 10. I want to consume messages that contain the word Brett, right? It's actually examining the content of the message. These are things that Rabbit doesn't do so well. Okay. Go into that. Queues in this deck message queue product are numbers, right? They can be numbers between 0 and 10,000, 9999. Okay, that's fine. But I don't know who came up with this idea, but numbers actually have meaning as well. You know, like in the range of 4,000 to 6,000, that's reserved for a certain type of queue and so on and so forth. But hey, that's no problem. In our wrapper API, we can handle this logic, even though it's a little bit strange, and we can map that to real RabbitMQ queue names. Not a problem, pretty straightforward to do. There's no graphical user interface. Developers, or users rather, can't create queues other than temporary queues on the fly. So all of the routing and everything like that, all of the topology, I suppose you would call it, needs to be set up in advance by an administrator before you let your applications run on this infrastructure. That's not a problem. That's a non-problem from a Rabbit perspective. What do we want to say about this? Yeah, so it also provides a naming service. This is kind of odd. I mean, queues are essentially numbers. I want to talk to queue number 1 and group number 3 or something like that. But you can also give them names. So in terms of my replacement solution here, we needed to provide a name server. Okay, the name of the queue is Fred. What is that in numerical terms? 3.1 or whatever. We need a name server to actually retrieve that information. Easily implemented using RabbitMQ, of course, just using the RPC messaging pattern. Hey, what's the location of queue Fred? It's 3.1 or something like that. I mentioned before about journaling, easily handled with streams and so forth. And things like dead lettering and so forth, this is all trivial stuff for Rabbit. So as you can see, a good deal of overlap between the old and the new technology. So what I've done for one particular customer in the United States is we've implemented this solution. It's looking really good. There are some features, like I mentioned, that RabbitMQ just doesn't do because they're essentially bad, naughty, evil things that you just don't want to do. And invariably what I'd say with all of these projects is there needs to be some level of compromise. You're never going to get 100% fit. Maybe you're going to get 80%, 90%, you might even get 95%. But the bit that you're losing, the few percent that you might be losing in terms of functionality, I think generally speaking customers understand that you're actually gaining a heck of a lot more by getting rid of this legacy proprietary thing and sticking in something new and modern like Rabbit. It just opens up a whole raft of new possibilities to those customers in terms of how they can route their messages and the interesting things that they can do. So I've managed to race through this incredibly quickly. Not all message queuing solutions are created equal, but they do share an awful lot in common, and that presents opportunity. Okay, products like Rabbit provide a great deal of flexibility and provide an excellent solution for the types of scenario that I've been talking about. Very flexible, quite extensible as well. You can implement your own new exchange types if that happens to be something you needed to do for a particular customer, whatever. You can do all sorts of fun stuff. Okay. And the use of standards, of course, is important. No question about that. No problem getting skills for something like Rabbit. You know, you try and find someone who knows anything about DEC message queue, for example. They've pretty much mostly retired. I suspect I could count on the fingers of one hand the expert consultants that I could find. Okay, so just to quickly wrap up, some of you might have been here in 2023 when Alvaro did his talk. The other thing I think that has happened, you know, AMQP was born of frustration. I think John O'Hara was originally aiming for primarily financial services, but this stuff just took on a life of its own. And I think AMQP, one way or another, has introduced a whole new generation to the virtues of message queuing, and that's absolutely fantastic to see as someone who's used message queuing for pretty much the entirety of their career, one way or another. And you can use this new technology, AMQP. I've referred to Rabbit here, but equally could be Azure, Message Bus, any AMQP implementation, be it 091 or 1.0, I don't care. You can use the same sort of techniques that I've raced through here to actually integrate those sorts of message queuing solutions with your customers' legacy applications. And you can see from the numbers on Alvaro's slide, maybe you can't read them, but there's some pretty terrifying numbers in terms of throughput in Azure messaging, and I dare say it's the same for the likes of AWS and Cloud AMQP and so forth. Some of the customers that I've been working with this stuff, just to, you know, to give you a rough idea, you'll see words like Fortran, Pascal, Basic, COBOL. You know, this is reality, okay? These are customers with old applications that run their business. They're absolutely critical to their business. They can't just switch them off and replace them. It would be tens of millions of dollars of expense. By plugging in message queuing, using techniques like I described or something similar, they can actually do an awful lot more with those applications going forward. The old stuff's not going away anytime soon, okay? And there's a lot of it out there. Let's have some fun. Done.
We had a few minutes for questions. Any questions for Brett?
Damn, the IBM guy.
I thought that was a session of two halves. When you got to the DEC part, where it was a legacy messaging technology with no support, got it. What's your definition of a legacy messaging technology?
This is why I apologized to you at the start of the talk, because I actually had the realization that it is that second half that really is the big deal here. Yes. But, you know, to be fair, I don't know. Maybe it is a stretch, because you guys have done a lot to enhance MQ over the years. TIBCO have done a lot with TIBCO over the years. I'll have to eat my words on that one. But yes, you're 100% right. I think it's the game of two halves, to use the rugby analogy, and it was definitely the second half is the message I really want to get through. Yep.
Great. Totally agree with that. By the way, AMQ 1.0, if you want to use that with MQ, you're more than welcome.
Oh, I know, and I do. I actually, I'm working with a customer in the US doing exactly that. Yes. Yeah.
You don't need a COBOL wrapper.
No, I know.
Any other questions? All right, let's thank Brett for his talk one more time.
Yeah.